All right, so we're going to do one last problem in our sum of a geometric series. We're just going to do a word problem because these can show up too. Excuse me. So take a second, pause the video, read this so that you understand what we're talking about. So hopefully you can see that this is a geometric series because we need to figure out the total prize money they need. So the first amount that they need would be the $1,000 for first place. And then second prize is 3/4 of that. So you could calculate it, or we can say, well, that's going to be 1,000 times 3/4. And then third place, we're going to take that second place amount and multiply by 3/4 again, which is doing the 3/4 squared. And then 1, 2, 3, fourth prize. Again, we'd have 3/4 squared and then times another 3/4, etc. And hopefully you see that this is geometric. So I want to know the total amount. We're going to keep doing it until we have all 25 prizes. So we are trying to find the sum of those 25 prizes that they need to award. And so we're going to start with our first term in our 1 minus our common ratio. What are we multiplying by every time? Our amounts are 3/4 of the previous amount. And then we're going to go to the 25th power because we want 25 prizes. And then we can do 1 minus 3/4. Again, if I was typing that in my calculator, I would definitely want to do parentheses. So at this point, you should pause this video and see if you can come up with the answer. I thought I'd just show one more example here of how we're going to type this in. So just because of all the parentheses and things. So we can do 1,000 times, and now I need my parentheses for the top. We're going to do 1 minus, again, I always put my fractions in parentheses. We're going to go to the 25th power. Then I want to get out of having a power. I'm going to divide by, again, parentheses, so many parentheses. 1 minus my 3/4. I don't really need this parentheses around the 3/4, but it's better safe than sorry. Close that all up. And then shazam, there's my answer. 3,996.98 cents, or 99 cents. So I think we probably would want to be safe, we would need $3,997, or, you know, $4,000 if we're thinking of a good round answer. Okay, so then I have one more sort of corollary question. It says represent this problem using sigma notation. So let's just see if we can do that for a little extension. Okay, so I'm going to be adding up a bunch of numbers. And I want the first number, and we just said we have 25 prizes. So I basically want 25 different numbers to come out. And my formula is that geometric sequence formula, right? Not the geometric sum formula, not the A1 times 1 minus r to the n over 1 minus r. What goes in here is the sequence builder. So right here is my sequence builder formula, which in this case, I start with 1,000. I'm going to actually get rid of this. And I'm going to multiply by 3/4 and minus 1 many times. So when I is 1, I am not multiplying by 3/4 at all, because 3/4 to the 0 is 1, and that gives me a first prize number of 1,000. And when I is 2 is when I'm doing 3/4 of 1,000. And when I is 3, oops, this should be an I, right? For consistency, I could say n goes from 1 to 25, whatever, but this guy right here, this letter should definitely match this letter. So I could have, this would be totally okay too. 1 to 25, 1,000, 3/4. That's the same answer. So it's going to get me all the same numbers out, and I'm going to add the same number of numbers. So that's a little word problem. Now you really should be able to find the sum of a geometric series and represent a series using sigma notation. That was that last quick question. So hopefully you have what you need. Any questions, come to a hangout. Bye.